In the summer of 2021, a field biologist conducting a routine survey transect inside Big Cypress National Preserve logged a data point that would sit unexamined in a research archive for nearly 2 years before anyone understood what it meant. Python detection rates in 3 separate monitoring zones had dropped not within seasonal variance, not within the margin of error, but by a figure significant enough that when Dr. Elena Marsh ran the full 7-year density comparison, not one of her existing models produced a viable explanation. The zones shared a single defining characteristic: zero targeted removal pressure. No hunters, no traps, no human intervention of any kind. The pythons were disappearing, and nothing in 40 years of Everglades conservation science had prepared anyone to explain why. This is not a story about a government program working. What researchers at Big Cypress documented across a multi-year forensic investigation is something the scientific literature had no framework to anticipate, and the evidence trail that led them there began not with a data set, but with a carcass lying in the pine needles with its head completely gone. 4.5 meters of muscle, 40 kilograms, a GPS tracker still attached, still transmitting. No drag marks, no blood dispersal, no disturbance consistent with a struggle of that scale. Just a body, intact below the neck, and a wound geometry so precise that the first forensic assessment couldn't immediately determine what class of animal was even capable of producing it. Burmese pythons had no natural predators in this ecosystem. That was not a contested claim. It was the foundational assumption on which 4 decades of removal policy had been constructed. Think about that. Dr. Elena Marsh has spent 7 years conducting systematic population density surveys across Big Cypress, cross-referenced against 3 decades of FWC monitoring data. Ian Bartoshek, wildlife biologist with the South Florida Water Management District, has independently reviewed the forensic evidence. Their combined conclusion is not speculative. It is documented, repeatable, and supported by trail camera footage that the research community is still working to fully process. The official story on Burmese pythons is not wrong. A single reproductive female produces up to 100 eggs per clutch. Mammal populations across surveyed Everglades zones declined between 90 and 99% following python establishment. Human removal programs, despite extracting tens of thousands of individual animals, have never mathematically kept pace with that reproductive output. The science on this is sound, and no serious researcher disputes it. But in 2021, something in those 3 unmanaged zones changed, and what Dr. Marsh found when she finally turned her attention to the trail camera archives changes everything we thought we knew about what is happening inside this ecosystem. The carcass was discovered on a Thursday morning in late October 2021 by a researcher who had been in the field for 6 years and had never logged anything she didn't have a classification for. She had one now. The python measured 4.5 meters from the base of its severed neck to the tip of its tail. Its GPS tracker was still attached at the mid-body anchor point, still transmitting coordinates, still functioning exactly as designed. The signal had gone dark 2 nights prior, and the working assumption across the research team had been equipment failure, a dead battery, a water intrusion, a hardware malfunction. Equipment fails in the Everglades. That happens. What doesn't happen is a 40-kilogram apex constrictor turning up in the pine needles with its entire skull removed and no physical evidence that anything in this ecosystem had the capacity to do it. Not a drag mark, not a blood trail, not a single displaced section of ground vegetation consistent with a struggle between 2 large animals. The surrounding pine needles were scattered across the upper body in a pattern that FWC forensic analysts would later describe as post-mortem disturbance, as if something had briefly covered the carcass and then departed. The wound itself was the detail that stopped everyone. Clean severance at the atlas joint, the precise anatomical junction where the skull meets the cervical vertebrae, with wound geometry indicating a strike force and bite angle that the initial forensic team could not immediately assign to any predator in the documented regional fauna. Let that land for a second. A 15-foot python with no natural enemies in this ecosystem, dead in the open, with no evidence that it had fought back, and a wound that the first experts to examine it could not explain. This is a Type C forensic scenario, a physical discovery that precedes the explanation, and its significance is not symbolic, it is evidentiary. The Florida Fish and Wildlife Conservation Commission has documented 17 comparable carcasses between 2021 and 2023, each sharing the same defining characteristics: full body preservation, cranial removal, minimal to zero struggle indicators. 17. Across a 2-year window. In the same geographic corridor where Dr. T.B. Elena Marsh's density surveys were already showing declines no removal program could account for. The pattern was not random, it had a shape. And the shape was pointing at something the research team had not yet allowed themselves to name. Because the foundational assumption of Everglades python management, the assumption embedded in every removal program, every funding proposal, every conservation model built since the 1980s, was that Burmese pythons in South Florida had no natural predators. Not ineffective predators, not occasional predators, none. Something had just changed the rules without telling anyone. If this mystery is already challenging everything you thought you knew about the Everglades, hit subscribe right now. We go deep into stories backed by forensic evidence. Now, back to the data, because before we can show you what the trail cameras revealed, you need to understand the full scale of what this animal had already done to this ecosystem, and why the math of human removal was never going to be enough. Now, here's what you need to understand about the Burmese python, because without it, nothing that follows makes any sense. The python did not gradually infiltrate the Florida Everglades. It detonated. The first confirmed breeding population was established in the early 1980s, most likely the result of escaped or deliberately released pets following Hurricane Andrew in 1992, which destroyed a breeding facility and introduced an unknown number of animals directly into South Florida habitat. Within 2 decades, population estimates had reached into the tens of thousands. By the time federal and state agencies recognized the full scale of what was developing, the animal had already threaded itself through millions of acres of wetland, sawgrass prairie, and hardwood hammocks so thoroughly that conventional wildlife management had no operational template for what to do next. The population math is the part that produces despair in the researchers who work it. A single reproductively mature female Burmese python produces an average of 50 to 100 eggs per clutch, with documented cases exceeding that figure. She does not need a consistent male presence. She can store viable sperm. She coils around her clutch and generates metabolic heat to incubate it, staying with the eggs through a 6-day gestation with a hatch success rate that field researchers have documented at over 85% under normal conditions. Every female added to the population is not one snake. She is a compounding reproductive unit that the removal programs have never been designed to neutralize at the pace required. The removal programs themselves are not failures of commitment or funding. The Florida Python Challenge, the state's most visible removal initiative, mobilized hundreds of contracted hunters across multiple annual events and produced removals in the thousands. The FWC's year-round removal program has extracted over 20,000 individual animals since its inception. These are not trivial numbers. 20,000 snakes removed from a single ecosystem represents an extraordinary sustained effort. And yet, according to population models maintained by the U.S. Geological Survey, these removals have not produced a measurable reduction in overall python density across the Everglades system. Not a plateau, not a slowdown. The population has continued to expand. Think about that. 20,000 animals removed, and the needle did not move. What that sustained predation pressure did produce, however, was a documented record of ecological collapse that no serious scientist contests. Long-term monitoring data, published across multiple peer-reviewed studies, shows mammal populations in heavily python-occupied zones declining by 90 to 99% compared to pre-establishment baselines. Raccoons, marsh rabbits, Virginia opossums, white-tailed deer fawns. The bobcat, the same animal that would later become central to this story, saw its own population in certain monitored zones reduced to near undetectable levels. The python did not disrupt the food web. It removed it, methodically, silently, and at a scale that took researchers years to fully quantify because there was simply nothing left to count. But while researchers were focused on removal rates and population models, and the brutal arithmetic of a reproductive machine that human effort could not outpace, something else was quietly developing in the background. That background development began with a number that didn't belong. Dr. Elena Marsh had been running systematic python detection surveys across Big Cypress National Preserve since 2016, using a standardized transect methodology cross-referenced against GPS-tagged sentinel animals to produce density estimates that the research community considered among the most rigorous in the field. By 2022, she had 7 years of continuous data, enough to identify seasonal patterns, enough to model year-on-year variance, enough to know with confidence what a normal fluctuation looked like and what it didn't. What she found in 3 specific monitoring zones in the northern section of Big Cypress did not look like variance. Detection rates had declined by a margin that fell outside every confidence interval her models could produce. Not slightly outside, significantly outside. The standard explanation for unexplained detection drops is methodological: equipment degradation, observer bias, seasonal movement pushing animals outside survey corridors. Marsh spent 3 months working through each of those alternatives systematically before she could rule them out. The equipment had been calibrated and functioning. The survey methodology had not changed. Seasonal migration patterns could not account for a decline sustained across multiple survey seasons in the same fixed zones. And the detail that made all of those explanations collapse under their own weight was the one she kept returning to. The 3 affected zones shared no removal pressure. No hunters had worked those corridors. No traps had been deployed. The FWC had no active program operating in those specific areas. Whatever was driving detection rates down in those zones, it was not human intervention. She spent the next several weeks pulling every trail camera archive logged across those zones going back to 2019. Hundreds of hours of footage across dozens of camera stations, sorted chronologically, reviewed for any behavioral pattern the survey data alone couldn't explain. And what she found across those archives is what changes this entire story. The first sequence that stopped the review team appeared on camera, Station 7, logged on the 14th of March, 2021, at 2:47 inches the morning. A bobcat field estimated at approximately 11 kilograms, based on comparative reference points in the frame, approached an active python nest site where a 4-meter female was in mid-incubation coil. What the literature would predict in this scenario is unambiguous. A mid-sized felid encountering a constricting snake 4 times its weight in a defensive posture over an active clutch would disengage. That is not what the footage shows. The bobcat held its ground, circled the perimeter of the coil at a controlled distance for several minutes, and then executed a series of feinting strikes toward the python's head that forced the snake to repeatedly break its incubation posture to track the threat. When the python finally uncoiled to reposition, the bobcat drove it away from the nest entirely and did not retreat. Ian Bartoshek, wildlife biologist with the South Florida Water Management District and a specialist in predator-prey behavioral dynamics with over 15 years of field experience in South Florida, reviewed that footage as part of the forensic team's independent assessment. His documented response was precise. Seeing 11-kilogram cat hold, its position, and force a 40-kilogram python off its own nest was, in his words, not something the literature had prepared anyone to see. When a researcher with that depth of field experience says that, it is not rhetorical. It is a professional admission that observed behavior had exceeded the boundaries of documented possibility. A second sequence, recorded 4 months later at the same camera station, shows what appears to be the same individual bobcat, identified by a distinctive marking pattern on its left flank, engaging a different python estimated at 4 meters in length. The encounter lasted 11 minutes. The python did not survive it. Nature is rewriting its own rules. If you believe actual evidence matters more than the official narrative, hit that like button and subscribe, because the next predator was even more systematic. But the bobcat was only the first layer of what the cameras were showing. The second layer was not a single animal operating alone. It was a coordinated group, and what it was doing to python reproductive cohorts in those 3 monitoring zones represents a level of tactical organization that the research team had no ecological category for when they first watched the footage. North American river otters are not, in the existing literature, documented python predators. They are opportunistic, highly intelligent, semi-aquatic mustelids that hunt primarily in water, targeting fish, crustaceans, and small amphibians. A solitary otter weighs between 5 and 14 kilograms. Nothing in their documented behavioral profile suggested they were relevant to this investigation. That assessment did not survive contact with the archive footage. Camera stations positioned near confirmed python nesting sites in the northern Big Cypress zones captured across multiple recorded events between 2020 and 2022. Groups of between 4 and 12 river otters approaching active python clutches during the nocturnal incubation window, the period when the female python generates and maintains body heat over the egg mass and is most physiologically committed to remaining stationary. The otters did not approach the female. They approached the clutch from the perimeter, using what Dr. Marsh's team documented as rotational harassment of the incubating snake while simultaneously accessing the egg mass from the opposite side. The technique was not random. It was functionally coordinated, and it was devastatingly effective. According to the archive data, groups of this size cleared between 60 and 100 eggs in a single event, using what field researchers have characterized as spinning bites that punctured and consumed eggs faster than the incubating female could physically reorient to defend the full clutch perimeter. In the affected zones, documented juvenile python survival rates have dropped below 15%. The reproductive pipeline, the very mechanism that made the python mathematically unstoppable, was being dismantled at the source. If you're seeing this footage for the first time, you're not alone. Even the experts were stunned. Subscribe and turn on notifications so you're the first to know when the next crack in the official story appears. And then there is the third factor, the one that explains the headless snake in the pine needles. The FWC forensic bite analysis team did not initially include coyotes in their suspect profile. That is worth stating plainly, because it reflects how thoroughly the existing framework had failed to anticipate what the evidence would ultimately show. Coyotes are a relatively recent arrival in South Florida. Their colonization of the peninsula only became well documented in the late 1990s and early 2000s, and nothing in their established behavioral coyotes record in any other region suggested they were capable of taking adult Burmese pythons as prey. They were not on the list. They should have been. The forensic breakthrough came from the wound geometry on the 17 headless carcasses. When the bite analysis team completed their tooth spacing measurements and mapped the strike angle on the atlas joint severances across the full carcass set, a consistent pattern emerged that pointed unambiguously to a canid specifically, to strike dimensions and jaw force consistent with a coyote, delivered from a 30 to 45 degree angle behind and above the python's head. That approach vector is not arbitrary. It corresponds precisely to the documented visual blind spot in the Burmese python's binocular field, the zone behind the skull that the animal cannot track without full-body repositioning. The coyotes were not attacking pythons. They were attacking a specific anatomical coordinate from a specific angle during a specific biological window, the shedding cycle, when the python's eyes cloud with fluid and its sensory acuity drops measurably for a period of several days. The python, during that window, is not invincible. It is briefly, measurably, exploitably vulnerable, and something had learned exactly when and where to strike. Coyotes did not arrive in Florida knowing how to do this. No population of coyotes anywhere in their documented North American range has been recorded executing this technique against constrictors. This behavior was not inherited. It was not instinctive. It was acquired, and that distinction is the most disturbing thing this evidence stack has produced, because it means the question is no longer what these animals are doing. The question is how they learned it, and how far that knowledge has already traveled. But here's where it gets truly extraordinary. The coyote's technique, the blind spot strike, the shedding window, the precise anatomical targeting is not a behavior that evolved over generations. Evolution operates across thousands of years and millions of reproductive cycles. What the forensic evidence is describing happened inside a single human lifetime, in a single regional population, against a prey species that coyotes had no ancestral exposure to before the late 1990s. That timeline is not compatible with genetic inheritance. It is, however, entirely compatible with something else: social learning. The transmission of acquired knowledge through observation, imitation, and behavioral reinforcement across a living population. This is the same mechanism that produced tool use in New Caledonian crows. the same mechanism that allowed orcapods off the Crozet Islands to develop coordinated wave-washing techniques for dislodging seals from ice floes, a behavior documented in some family groups and completely absent in others. Occupying adjacent territory. Knowledge that is learned, not inherited, spreads like that. It moves through a population along social networks, accelerates in species with high observational intelligence, and once it reaches critical adoption, it becomes functionally indistinguishable from instinct to anyone watching from the outside. Except it isn't instinct, it's strategy, and strategy can be refined. Dr. Marsh's team documented behavioral variation across the coyote population in the affected zones, inconsistency in technique, differences in strike timing, animals that appeared to be observing successful hunts from a distance without directly participating. That is not random variation. That is a population in the process of learning. The knowledge is still spreading. It has not finished moving. Think about what that means. Not for the coyotes, not even for the pythons. Think about what it means for every ecosystem where an invasive apex predator has been declared unmanageable because no native species had the tools to stop it. This does not mean the python crisis is over. The python crisis is not over. Let that be stated clearly, without ambiguity, before anything else. Python populations across the broader Everglades system remain at densities that dwarf the localized declines this investigation documented. The mammal communities that collapsed over 4 decades have not recovered. The ecological damage is real, it is ongoing, and nothing in this evidence stack should be read as a reason for complacency. That is not what this story is about. What this story is about is something far more difficult to process than a crisis. It is about what the crisis produced. A bobcat that learned to hold its ground. Otter groups that developed coordinated tactics no field researcher had ever categorized. Coyotes that identified a specific anatomical vulnerability in a 40-kilogram apex predator, determined the precise biological window in which that vulnerability opens, and transmitted that knowledge laterally through a living population, not through genetics, not through instinct, but through something that, in any other species, we would call culture. No government program coordinated this. No conservation budget funded it. No peer-reviewed framework anticipated it. 3 separate predator lineages, operating independently across the same stressed ecosystem, each arrived at a different solution to the same problem, and then, in the case of at least one of them, began teaching that solution to others. We don't just report on nature, we analyze the hidden patterns that institutions overlook. If you value this level of deep dive investigation, share this video, help us bring these hidden truths to light. And then someone finally asked the right question. Not whether the native fauna could fight back, the trail cameras had already answered that. The right question was, how long had this been happening before anyone thought to look? Dr. Marsh's data goes back to 2016. The behavioral variation she documented in the coyote population, the inconsistency in technique that marks a behavior still being learned, suggests the knowledge transfer began years before her earliest archive footage. The headless carcasses that the FWC formally cataloged between 2021 and 2023 were the ones that got logged. How many were never found? How many decomposed in zones with no camera coverage, no survey transects, no researchers to notice that the needle had moved? The evidence is in the archives. The truth is in the dirt. Drop your thoughts in the comments, we read every one of them. And if this video changed how you see the world, subscribe to Prime Discoveries. We'll see you in the next investigation. Because somewhere in the sawgrass tonight, the knowledge is still spreading, and it has been spreading far longer than anyone was watching.